The automobile, airplanes, electricity, the telephone, eradications of diseases, travel and space. These are great leaps in the concepts that have enhanced humanity in the developments that we enjoy in the world today. How did this all come to be? From the minds of thinkers who dared to operate from the far side of conventional norms and function within a realm that most people do not utilize. In Nigeria, our orientations are generally rational, molded through primary and secondary school educations. Later, they are reinforced in higher school learnings, and this provides a think tank that is too rational, unable to cope with new global irrational threats like HIV, Ebola, SARS, and other types of irrational threats and terrorism. How can Nigeria be competitive in a global race for development through new inventions and a mindset to face irrational challenges to the glory of the country? One Nigerian mathematician, Henry Oritshereneye Okotie, has an answer, a solution to what will enable all school leavers in Nigeria to work with concepts through rational and irrational modes and get more results.
Good day. Today is the 27th of May 2015. We are in Mina. Oritshereneye Okotie is my name, and I've been involved for the past 25 years in a research in the study of the irrational numbers. Over this period, we've come to realize that these numbers are crucial. They are necessary and sufficient, to enable inquiries into 21st century science, technology, engineering, and mathematics. These irrational numbers that we are exploring are required if we are to model precisely any biologically significant molecules. The structure of the diseases that we are experiencing sometimes, like HIV, AIDS, Ebola, and other virological diseases. The structures of these diseases are not linear. So it's imperative that we need to address the remedies, resolutions, solutions, vaccines, once we have the irrational numbers that deals with structures that are not linear. Thank you very much for the opportunity to go through the fundamental imperatives for knowing, the learning and teaching of these mathematical sciences. When Euclid, most of the work we are going to be doing here will be on Euclidean geometry, some experience from Euclid. One of the very first propositions he gave when he wrote the element is how do we construct? It goes something like, how do we construct a regular form from a straight line? So this is an exercise that they give to the students, and it enables the students to go into their wet way. And that's the process that we are going to explore from now. On a blank sheet of paper, it's important that we put on record the tools that are required. One of them is the compass. This we use to generate circles. The other tool is a straight edge. This we use to draw lines. And of course, it's very important that the plane is where we will introduce what is in our wetwares. And so, to deal with the question or the proposition raised by Euclid in his first proposition about how do we construct a regular form from a straight line. Before we go into that, we'll take the privilege to let you know that once we have 2 points on a plane, there are few things we can do. One, we can draw a line segment from one point to the other. Two, in fact, for vocabulary purposes, let's just call this first point A and the second point B. So we've drawn a line segment from A through B, and the other rule says we can extend, like I'm doing, to the right and to the left. These are line segment. So we've already answered the question from a straight line, part of it. The straight line, for us to do the straight line, we put those 2 points, and then we draw a line segment from point A through point B. And then we extended that. Doesn't matter. We center our compass on point A, going through point B, we construct a circle. We center our compass back on point B, going through point A, we construct a circle. We can invoke some of the masculine principles here. These 2 circles create this point above and below. We draw a line segment in green from this crossing of A and B above and the crossing to the crossing of A and B below. We can draw a line segment from this crossing. In fact, we can name this crossing C and this C prime. They are just vocabularies. Can be 1, 2, 3, 4. Can be space-time particle wave. It could be your physical self, your mental self, your creative self, and your spiritual self. It can be the color red, yellow, blue, and black. When we draw a line segment from point C to point B, we draw a line segment from point C to point A. And we draw a line segment from point A to point C prime and from point B to C prime. You notice that an equilateral triangle ABC above, the AB line separates the concept of above from below. And for symmetry purposes, you notice also that we have A, B, C prime. These are regular forms. the inquiry by Euclid to the students is unfolding, and that's the way. Then we notice also that when we drew this line segment, we came to this crossing. This crossing was not there initially, and we came to this crossing. These are things we're supposed to have mentioned before. Now, I'll draw a line segment, use color coding to separate some of like the black circle form from this green circle form. That's the form. The regular equilateral triangle above, equilateral triangle below. And in the process, we still found out that another equilateral triangle in green and another equilateral triangle in green.
These shapes are also visible in normal everyday settings around our surroundings, like the entrance to the ancient capital city of Minna in Niger State, Nigeria. This is the palace of the Emir of Minna, also in Niger State, Nigeria. You can see that the ancient architectures here have also embedded the forms and shapes of sacred geometry on the walls and structures of these massive palace infrastructures.
You just saw forms. What is really sacred geometry? What do we mean when we say the word sacred geometry? When we engage the geometry as the method of relating to our day-to-day activities, it opens us into other unfoldments. If we expose the children and also us, the confidence in our ability to learn becomes reawakened. The confidence in our ability.
Mathematician and geometrist Oritshereneye Okotie has been teaching his studies of irrational numbers and shapes in various school districts around the United States of America for many years. He has used it to challenge children and their teachers to identify various possibilities in their abilities to solve mathematical and scientific problems. It is his hope that he can use these methods successfully here in Nigeria to train future candidates for mathematical and scientific oriented institutions and for pharmaceutical companies.
These pharmaceutical companies, we need to engage them and let them know that encouragement to their research teams, that they've been recovery of the more ancient vector numbers, the geometry, pre-Euclidean geometry from ancient Egypt, has given the opportunity to the globe. It's now a global thing that they can now use these numbers, irrational numbers, to enhance their research in the cure or vaccine for these virological diseases, AIDS, Ebola and HIV and other hepatitis, all kinds of stuff. Because the structure of these diseases and other diseases on their cellular level, the structures are not rational. They are irrational structures. And so those are the way the forms, the objects of these diseases appear. If you take a microscopic nature and see these structures, they are in forms of a triangle, a square, or a pentagon, or a truncated version. These diseases are, you see some stuff like looks like a square, but it's actually a pentagon. And before your eyes move from that, another form has, there's so much forms that, so numerous forms that, but that is what will enable the scientists to get a clue to the vaccines they are trying to produce to help mankind. So these numbers will help them, help mankind, like the 0 and 1, help us, enable a lot of computation. And today we have computers, we have satellites, we have planes, all modern technology, internet is from that. So these radical vector numbers will even do more in terms of growth. The type of growth in all areas, whether it's science, engineering, mathematics, theoretical, or practical, is enormous. The magnitude is in an exponential growth. What do we mean when we say the economy, Nigerian economy, is growing exponentially in all areas? Like what? Like in architecture, infrastructure, in sciences, in arts, and in law. We have to have a vision, the country.
We have seen that from a blank page to very simple forms and shapes, even colorful and playful to the eyes, more complex representations can be generated, and to their most precise forms and applications.
And this small triangle, and this small triangle, and this small triangle, and this small triangle, and this small, they form on this blue circle, 6-pointed star. The relationship between this equilateral triangle and this equilateral triangle. It's like looking at the cloud, and people tell you all kinds of shapes. Look, they sing the angels flying. At this stage here, it seems like these forms, they'll be a little bit more complicated. But as we go along in terms of the deconstruction, we're going to deconstruct this form. I think that's what we call synthesis. Or build this form from beginning. Initially, for this drawing, for those that didn't follow us, these were the first 2 points. We centered our compass at this point. Going through this point, we constructed this blue circle. We centered it back at this point. Going through this point, the compass, we constructed this blue circle. This blue circle, the first one centered here, and this blue circle, the second one centered here, they cross at 2 places, above this point and below this point. At this point above, we center our compass again, keeping the same radius. We constructed, coming through A and B, we constructed this blue circle. Then the next thing, we came to the crossing of the first circle and the second circle below. Centered our compass, still keeping the radius. It enables us to construct this very circle. Now, the next thing we did in red, we drew a line segment from this point to this point and we extended it on both sides. Then, we drew a line segment again from this point to this point in green and we extended it. We drew a line segment from this point to this point to this point. We drew a line segment from this point through this point to this point, and so on. So we can say, when we look at this diagram, that the green line segments are perpendicular to the red line. The green line perpendicular to the red line. The green line perpendicular to the red line. The red line perpendicular to the green line. The red line perpendicular to the green line. The red line perpendicular to this green line. But this small green circle here is a circle that is divided into three parts. 1, 2, 3 initially. But with certain other crossings, we found out that this same circle that was divided initially into three parts are now divided into 1, 2, 3, 4, 5, 6. We cannot understand or overstand this vector arithmetic. Its canonical, thought process is about the crossings. Actually, all what we are doing is about the crossings. Points on the plane. So we can achieve these points by the crossings of the circles like this one and this one, the crossover here. Or the crossing of this one and this one, the crossover here. Or the crossing of this one, this is a circle, and this circle, they meet over here. So it's circle to circle. Then the other key, point is lines. Drawing this line segment, and these are very important points. We didn't stress them here at this particular time, but, so we go back, lines and circles. We go back, lines, and circle. Lines and circle. Then the third one, in terms of these crossings, is the lines and lines. Lines, the red line, and lines. So all of the manifestations of these points on the plane comes about through the crossings of circles to circles, circles to lines, and lines to lines. Period. So you speak precisely what you say, you say what you see. It's not saying some stuff that you don't know what is happening. We're going to discuss about spaces also down the line.
Certain things we see, they make us wonder so much about them. Some things we feel, we're thinking, now who go tell us about that? A river, a mountain, the sun, the moon in the midnight sky. I wanna sit down and think about it. I get this feeling like I'm under a moon, down by the bank of the river, watching creation, discovering creations and certain things we love. We take it all for us, they're all near extinction. Some things we make, the greatest things in the world that cause extinction. A building, a teaching, a war. Do you remember a life you take? The earth is for life and life's for the earth. Don't fall a giant just to get a tusk. All that we have, we're just fuels for the earth. Not a dollar, a euro, a yen, a rand, a peso. Oh, certain things, they put us in a bad